Hello Internet, today we are going to be playing with mesh generation. So I have a quad here right now. It's just a really simple 4-point thing. Can show you the wireframe quickly. That's kind of hard to see. Actually, that's really hard to see. There, that makes it a little bit better. So what you get with geometry, with 3D geometry, is everything is composed of triangles. In this case, it's a quad, so it's 4 sides, just a plane. And there is 4 points on it. There's 1 in each corner. And then you have to set up the faces that actually exist on that. And those are going to be 3-dimensional things. Or they're going to be, it's just going to be 3 connected vertices. So 1, 2, 3 makes this triangle. And then 1, 2, 3 makes this triangle. And then when you combine them, you end up with this, which ends up turning out to be something like that. So what we're going to do is I have another empty object over here. We're going to be generating another quad that's going to look almost identical to that. And then the idea is we're going to be playing with mesh displacement. So the idea is if you've played Tomb Raider, where you walk around in the snow and the mesh kind of moves out of the way and the snow kind of depresses when you walk over it, we're going to be working on that. And so to get that, what I wanted to start with is just some basic. Let's build the mesh from scratch, and then we can use that to manipulate it all. So we're going to be starting with this. We have nothing. There's nothing here. This is the same project as our Blizzard script, but other than that, it's going to be totally new. So we're going to generate a plane mesh. And so there's not anything here. And what we do need is, you can see they've got this mesh filter, the mesh renderer, and then a mesh collider. So we're going to need the mesh filter and the mesh render. The mesh filter holds the mesh that you're going to be rendering, and then the mesh renderer actually renders it to the screen. So we are going to add both of those to this. So let's just do mesh filter and a mesh renderer. And now what we need is we need a script that's going to generate a mesh, set that here, and then this will draw it. And I don't know if we need a material. Let's just assign it one. Torch, terrain. Sure, that'll work. So it should be textured with the terrain material. And it will use whatever mesh we assign there. So we've got our generated plane mesh, so I can actually add that as well. And then all we need to do is actually write the thing. So let's open this, run through this. Clicking all the buttons. Let's see. So what we have is we have a generate mesh. We're going to need a reference to our mesh filter, which is going to be our filter. And then I think let's do a public size. And so if it's a size of 1, it will have a total width and height of 1 on each side. Then all we need to do is actually generate the mesh, which we're going to create a separate function for that and return a mesh called generate plane mesh. We can't actually call it that because that's the name of our class, and that would break everything. But we can call it generate mesh, and then in here, all we want to do is set our filter dot mesh equal to our generated mesh. And so once we get this implemented, everything should be good. Return statement is missing. Well, yeah, I know, I haven't finished it yet. So we've got a mesh, and we just need to return it. Done. Now the issue here is it's never assigned. So we'll create a new mesh, and that should be good. Now this isn't going to work. Actually, it really isn't going to work because I'm not getting my filter. So we're going to get a component of our mesh filter, like so. And then I'm just going to require that up here. So if we require our mesh filter, then we can actually grab it here and use it here, and then everything else should be good. What we should do is we should be able to run this now, and we should, if everything's working right, we should see our mesh. We should see our mesh generate and be assigned, but we shouldn't see anything drawn because there's no points assigned. We may get some errors as well. So there's no mesh still. Wonder if that's no. So part of the reason we're getting these exceptions is because normally I have ProBuilder, and that would go right here. And whenever I click here, Unity tries to look up whatever window is supposed to be there. It isn't there because I don't have that in this project, and it gets really angry. So we can ignore this error. It's irrelevant. But if we see any others, then it's important. So we need to figure out why it's not working. It's been a while since I've done this. Actually, it's been a long while. So we should just be able to set it. I don't think any of this is wrong. What we do want to do, though, is actually generate this. So what we're going to do is set the vertices to a new list of vector 3s. And I'm just going to generate those in line like this. And so we can do a new vector 3 of negative size over times 0.5 and negative size times 0.5. So we're going to start over in this corner. It might be a little bit reversed for you. But no, actually, I think I've got it fixed. Okay, should be over here. And then we'll go over here, down here, and over here again. And that should be our mesh. So if we start in the top left, I believe that's where that will be. And we actually want to go on the XZ plane. So Y is going to be 0 in all of these cases. And then I can just do something like this if I type it right. Or not. There we go. There. So now all we need is we need to fix this. So we'll move it to the right. Then we'll move it down. And then we will move it back over to the left. So it should go like that. And then our final point is somewhere down here. So we've got our vertices. And then if we look at what this is doing, if I look, actually it might be easier if I do, yeah, that's easier. So we've got point 0, 1, and 3 form this triangle, and points 1, 2, and 3 form this triangle. So we can go here and do mesh.set. What are we setting? We are setting the triangles. And so this is going to be a new list of ints. And I believe you're going to have to bear with me here because this is kind of guessing. But if I remember how this works, it's not like this, apparently. What's going on? No argument takes one. Oh. Submesh 0. Okay, one sec. I'm going to figure out what that is. Excluded from the docs. I believe we can keep it at 0. So I'm going to keep it at 0. I don't think there's any submeshes we need to worry about. Could be wrong. And then I may have to actually use my Google foo, but for now it should be good. So how this triangles thing works, if I remember it correctly, which I probably don't, is you give it has to be a multiple of 3. And so the first 3 numbers are going to be your first face. So we said 0, 1, and 3. And then the next ones, 1, 2, 3, are going to be your other triangles. So we've got 2 triangles here. We've got 0, 1, and 3, and 1, 2, 3. And that should be both of them. Then the only other thing we need is we need normals. And these are going to be in object space. So they can be relative to the mesh, not relative to where you want them to point in the world. And so since our plane is like flat, we actually want to generate them pointing straight up, which makes it really easy because we can just do set normals of a new list. And we're going to do the same thing again, except we're going to do vector3.up, and we're just going to do that 4 times. So now we have a plane that's all looking up. Everything looks good. And I think that's all we need. So let's see what happens if I actually try this. We'll get that normal exception, and then nothing happens. We made it facing down. So you can't see this. Now you can. But you'll see we did generate a mesh. And actually, I bet if I go down, there it is. So we were a bit backwards. Actually, we were exactly backwards. Our triangles are reversed, and our mesh is facing down. And so one of the things that Unity does to save performance is it doesn't render the back face of meshes. And so the reason it doesn't do this is consider like a human, for example. When you've got a big human model in your terrain, there's a whole back that nobody can see because there's stuff in front of it. But at the same time, it's still there. And so the same thing is happening here. We don't want to render that because that's just extra work that we don't actually need. But at the same time, that stuff is still there. That's why when you like walk into somebody or a wall or something, how you can see through them, even though there's still obviously material there. Meshes in 3D are sort of like just giant, I don't know, exoskeletons with canvas or something wrapped around them. It's very, very finicky. Anyway, what we need to do is we need to fix this. And we can do that in a number of ways. First off, we are going to switch this so it is the down vector, because that would fix it. And so what this is going to do is it's going to determine a normal vector is the direction that the face is facing. And so the best way to describe that is if you have like a sphere, for example, you know it's smooth, but the reason you know it's smooth is because there's vectors. It's the tangent vector, really. So there is something coming off of that perpendicular to it, not the tangent vector. It's perpendicular to the tangent. And so you've got your, well, I guess this works right here, but you've got your normal here. And so that's coming off. And you need to handle that somehow. And so the way that this works is that's what the normal represents. You know that, sorry, that doesn't make a bit of sense. So a normal vector is just the direction that the face is facing. So my normal is that way-ish. Still not very good at the whole normal thing. Best way to describe it is the normal is the direction that it's facing, the general direction. And if that didn't make any sense, that's probably for the best because I don't know what I'm talking about. Let's see. We've got this. All of those are good. That's all good. So we should be able to just make this and it should generate. Still facing down. I think I know what's okay. So it wasn't an issue with our normals. What's happening is something else. We'll get to that once I fix this. So I got a little bit ahead of myself. There are 2 reasons things are culled or not drawn. One is the normals are facing the wrong way. That's one way to toggle it. And there are toggles in like OpenGL or DirectX. You can change how it detects that, or you can turn it off entirely. the way that a lot of things detected it by default is the rotation of the vertices around that object, which sounds really weird, but you'll know, what's the best way to describe this? There isn't really a good way, but consider the way we organize these. So like, let's just say 1, 2, 3. There's two ways to go around this. You can go 1, 2, 3, or you can go 3, 2, 1. And so the way that they decided to calculate if something was facing forward or backwards is the rotation around that circle. So if it's clockwise, it's one way, and if it's counterclockwise, it's the other way. And so if you do 1, 2, 3 here, if I flip this over, you won't be able to see anything, but 1, 2, 3 is backwards. So 1, 2, 3 is now counterclockwise, whereas if I'm looking at it this way, it's clockwise. And so since that's flips, you can actually use that to determine which direction a triangle is facing. And that's how that's usually done. So the reason our mesh isn't showing up is because we have that backwards. So if I flip them around like this, we should be able to regenerate things and get our mesh. And there you go. We've got the same thing. The only thing you will notice is it's just gray. And it shouldn't be gray because we are assigning a terrain texture to it. Now the reason this is happening is because our UVs are very wrong. And so we need to actually set them. So let's do a UV. And what a UV is their coordinates on your texture or on your mesh that define where your texture is. So if we look at this, for example, you have a 2D object. And so a UV is U and V, I believe is the correct orientation. Could be wrong there. It could be very wrong. But the way it works is you need to map this onto that object. And so we need to take this and make it work. So what we're going to do is actually assign those. We're going to take this, set our UVs. I believe it takes another list. First it takes a channel, which I'm going to guess is... Don't know what that's for. I'm going to give it a 0 and see what happens. I would recommend looking at the docs before you just guess like I am. Mostly just guessing because if it doesn't work, then we'll figure it out from there. And if it does work, then, well, then it works. So we've got a new vector 2, which is going to be our U and our V coordinates. So we're going to start at 0, 0. And then we're just going to work our way around. And this has to match the exact same way. So we have, that starts here, and then it moves to the right, like so. And then it's fully down there. And then this one's 0, and this one's 1. And so it kind of walks around in that kind of circle-ish. So I should be able to rebuild this now, restart, and we should get our terrain on there. So you can see it is working. We're actually getting our terrain texture applied to our mesh, and that's what we were going for. Now the cool part with this is that's pretty much all we needed to do. We've got a really cool quad thing that we can just render dynamically and do whatever we want. If I want to make it bigger, I can do that. I can just give it a 5 there and have it go. And now we've got this really big quad that we can move around, and we can generate any mesh we want with this. I just set it up to do planes, but as long as you know what you need to generate, and there are functions for most of these things, then you can plug it in and do whatever you need. So the only other thing I want to do, as long as we're here, is I want to make this support more. I want to make this support more faces than it currently does. Like currently we can make a quad and it's all hard coded. What I want to do is I want to expand this so we can make it as many cells wide as we want. And so we can kind of subdivide this down. And that's going to be really, really key when we're trying to do all of our I guess when we're trying to come up with our displacement, we're going to want something a little bit higher packed than just a 1 meter thing. And so this should help that. So how we're going to do that, we're going to plug in a grid size, sure. And we'll give it 16. So it'll have 16 cells, which means we're going to want to make this bigger. And then I'm going to delete this other quad because we don't really need it anymore. That was just for reference. And then all we need to do is actually use that. So we're generating our mesh with 16. And what we need to do is create a new list of vertices that is going to map to that. And so this is going to take a little bit of thought. So we have one quad. When we place another one beside it, some of those vertices are going to overlap, and so we need to keep using those. Yeah, so we're going to have to be clever about this. And the way to do that is a bunch of for loops, because for loops are good. Anyway, let's see, grid size, got it. And we're going to do another one for our X. So we can do this. And so all this is going to do is it's just going to loop over our X and Y axes. I'm using X and Y because we're working as, think of it like a 2D graph. We're just working like that. And then we just need to subdivide that a bunch to make all of this stuff. And so to do that, we're going to make a bunch of lists. We're going to have a vertices. We're going to have a vertices list, which is going to be a new list of vector 3s. And we're going to have a triangles list. Actually, let's hold off on that. Let's do a normals list. And that's going to be another vector 3. And then we need our UVs, which is going to be another list. And that's a vector 2. So what we need to do is we need to take, I'm trying to think of the best way to do this. Let's see. We take our vertices and add a new vector 3 that is at negative size times 0.5 plus the size, and then we need a fraction here. So we're going to do, I don't like this, float of our X times our grid size. No, yes, no. No, that's wrong. We need to divide by a grid size. And this is going to be weird. So I'm actually going to stick the casting over there. And make sure all the order of operations happen in the way I want them, because that is going to be very important. All right. So this looks gross, and that's kind of unfortunate. But what this is going to do is, once I get it completed, it is going to calculate the X and the Y position of our grid. And so, there we go. So let's walk through this. What it's going to do is it's going to start over in the top corner up here, and then it's going to iterate over the X and the Y in our grid. And then for each of those points, it's going to walk through. I think the way we have it oriented, it's going to go actually down first. It's going to go down this Y, and then it will go across and down and down, across and down. And so what this is going to end up doing is it's going to take the x, divide it by the grid size. So that's going to get us a fraction of how far across our plane we are. And then it's going to multiply that by the size. And so this total will only ever equal the total size we want it to be. And since we started over here at half of our size, that will mean that we will eventually cross the entire size and it will just equal that. So now we need a normal equals, we want to add a new normal, which is going to be a new vector. Actually, we don't even need that. We can just do vector3 dot up. That works. And then our UV is going to be similar to what we did here, but hopefully a little bit cleaner. So we can do this, and then we want our X divided by the float of our grid size. And then this can be Y divided by the float of the grid size. And so this whole thing is going to generate our vertices, our normals, and our UVs for us. The only hard part then is we actually need to group everything and convert it all into triangles and then make it render the whole thing. And so, let's see, for every 4, there's going to be 2 triangles. And so we can use that, I think. How are we going to do this? No, this will work. Okay, so we're going to create a new list of ints. Yeah, okay. So we've got our new list of triangles. And then we want to do a for each index where I is 0 to I is less than the grid size times the grid size divided by 2. Right? So if we have, for every 4 vertices, which is what we're measuring there, we're going to have 2 triangles. So by taking the grid size squared, that will be the total number of vertices in our graph or in our plane. And then if we divide that by 2, that should get us the total number because we have a 2-to-1 ratio. Yep, I'm going to go with that. So now that we have that, we should be able to actually implement this and get it working. And it doesn't like this. Set the triangles. Takes 1 argument, right? Submesh 0. So I'm just going to quickly fill out this while I try to come up with something clever so I don't look silly when I'm writing this. We're going to set the vertices. And then we're going to set the normals. Sure. And then we are going to set, that's not how you do that. There. And then let's set our UVs. There we go. Okay. It didn't like that. We're missing something. Channel. There we go. All right. So now we need to implement this. And so we might actually be able to do what we were doing previously, which was a 310. I'm just going to comment those there so I don't forget them. 310 and 321 were our 2 triangles. And so what I'm thinking is for each vertex, we should be able to just generate both of those. Right? So we should be able to go down, or we should be able to start at 1, generate those 2, and then go down and generate those 2, and keep doing that. So I think I can just do something like this. It's going to be I plus 3. Ooh, that's not how you do that. We're going to add... I suppose we could just add a range. Let's try that. So we're going to do a new list of integers. Sure. This isn't going to be optimized. I'm just trying to get this written. Obviously, spinning up a whole new list like this is overkill, but we're going to do it because that's what I want to do. So we're going to add that. We're going to do an I plus 1 and an I plus 0. And I'm just doing the plus 0 because that way I know what's going on. Just I sitting there is, I think it's confusing. So we're going to try to make ourselves a little bit happier. So hopefully this should add everything to our triangles list. And so the idea is it'll start at the top, add the 2 triangles to its right and down, and then it will move down because that's the way we set it up. And it will add those 2, and then it will move down and add those 2, and so forth. Now the only thing we want to avoid is if it's the 15th element in the list, we don't want it to do anything. Or sorry, not that we don't want it to do anything, but if I plus 1 mod the grid size is equal to 0, then we want to continue. And so this is going to stop us from trying to generate triangles from the bottom to the top of the next row. We don't want that to happen. Once it gets down to that second to last column, then we're done, and it will have already finished off the bottom. Because it's going, we're getting little squares like this, like this. And so we're going down and down and down. And so what we want is we want each of those squares to be below and to the right. So theoretically, this is going to not iterate over the right side, and it's not going to iterate over the bottom side. Could be wrong there, and if I am wrong, we'll see some very interesting errors. But if I'm right, it will work. There's one way to try. So let's see what happens. We're going to start it, and we get, ooh. That's all kinds of messed up. So it's on both sides, and it's doing some weird razor style thing. This wasn't at all what I expected. It looks like we are getting very much off by lots. Oh, I know the issue. So we had 3, 1, and 0, and so forth. That's not actually correct. So we were accounting for just one grid. That's not right. That's not going to work for us. And the reason that's not going to work is because we are doing wrapping. So there's actually not 3 here. There is a whole grid size in there. So we're going to do a grid size plus 3, and the 2 is also going to be on the other side, if I'm remembering this correctly. So 0 and 1 are going to be over here, and 2 and 3 are going to be on the other side. Could be mistaking that, and we'll know if I'm wrong, but I believe that's what was happening. Ooh. These are cool. I like these, but they're not what I wanted. They're not even close. So they're the wrong size. You can see they're not the right size, but they're also all over the place. And that's a little bit, whoa, upside down and concerning. So we're getting to like the center and then it's just stopping. And that's still not, it's still not throwing any exceptions, which is good, I guess. But it's certainly not working. And what it looks like is happening is it's taking this point and rendering it there. So I think we're still off by a few. Well, we're off by more than a few, but so that's going down there and there. Okay. So I think what's happening is we're starting here and we're going too low. We need to be up a bit, which means our grid size plus 3 is plus 1 actually, and our grid size plus 2 is plus 0. And so the reason we're coming to this conclusion is because we want our quad. And so we want to be like this. What was happening is we had our line here and our line here. And since we're adding 3, this one was ending up somewhere down here. And that was causing all of our math to be wrong. So now that we've theoretically fixed it-ish, it should look a little bit nicer. And it does. Half of it's right. The other half is very broken. But half of it's somewhat right. Still not totally right. But it looks like one half is upside down and the other half is working-ish. Ish is a good word for what this is. So what's happening here? It's going around, and this one's going around. I believe that might be wrong. We're gonna have to tweak this a bit and I'm trying to figure out which one is inverted because they're upside down. Ooh, that's wrong. So this is part of the issue is one, I'm trying to move relatively quick to keep this interesting, but also trying to find a way to do this. And it looks like we're still off. And we're not going all the way across for some reason. I wonder why that is. Why grid size? Huh. Well then, this is working well. I'm going to remove that and see what happens. Imagine it's going to break things. Yes. Yes, it did. That is good. Okay. Index count, a lot. Vertex count, not that much. Cool. That means I was right. But I don't know what I was right about. Oh, geez. Next, move things around. I believe it's the top one that's causing the issue, but I could be wrong. We're just poking at things. This is what editing is for, right? Probably not going to do that. That removes all the fun of this. Okay, there's too much happening here. So I think, actually, yeah, there's too much going on here for me to tell what's going on. So I'm actually gonna shrink that down so it's 2. Oh. There's part of the problem. So what we should see here is, since the grid size is 2, there should be 2 vertices. Oh, that's probably the issue. So our math is wrong. Math is very wrong. We only made 2 vertices. I was counting cells before. Turns out that's not entirely correct. We need to add 1. And the reason we need to add 1 is because we are, what's the word for it? Off. It's the word for it, actually. So what's happening is we're taking our grid size, for in this case, we would be generating 2 vertices and 2 more vertices. Except that only creates a grid of 1, not a grid of 2. And so our grid was 1 too small. Whoa, lag a bit. So this is wrong. We should see something like this. So it's 4 wide, so we should see a grid here, and then our point is there, so we should see 2 more over there. And we're getting 1 or 2 correctly. So this is correct. The points are correct. But those 2 vertices are correct, and it appears to be just off by some margin. Did I not need this mod? I made it. Order of operations. It matters. In this case, I plus 1 mod the grid size, not the other way around. That's important. Ugh. There we go. Broke more stuff. But I broke it the right way this time. Which means... that's still wrong, but it's closer. Is it? Okay. One sec. Exploring the horrible land of trial and error. There we go. We're back to the same thing. And that makes perfect sense because that wasn't doing anything. I'm going insane. My mind is gone. Right. We're going to add that grid. Then we're going to add this one. This division by 2, I don't think we need that. And the reason we don't need that is because... there we go. So our mesh is being drawn. It's wrong, but it's being drawn. And so the reason we didn't need that is because there are more. No, that's the total number of vertices, so that's perfectly all right. And the goal of this is to make things harder after this. All right. We need to figure this out. Vert count equals the grid size plus 1. And so the vertices count is going to be multiplied by itself and then divided by 2. So we're doing the same logic we had. We're just accounting for our off by 1, which I believe should get us progress or not. No, that's right. Hold on. So I'm just moving things around at this point, trying to figure out where I went wrong, because I don't think it's anything too significant. This is our rotation bug, but we're missing two pieces. And I don't know where those ended up. Because what I would expect to happen is we'd go 1, 2, 3, 4, and then we, well, no, 3, 4, 5, 6, 7, 8, 9. But then we divide by 2, which would put us at 4 again. So it'd be here. So that would stop us. Okay. Is that our issue? I think it's the +1, honestly. And the reason for that is we don't need the +1 anymore because we're going by the vertices count. No, that's still wrong. I'm losing my mind. Okay. Let's see what happens. Something interesting, hopefully. That's not interesting. That's broken. Dang it. Okay. One sec. So, here's the idea. We have our grid count equal to 2. What we need... lights are on the whiteboard. So, we've got a grid count equal to 2. What we need is we need something like this. And one sec, you won't be able to see this. But we need this. Looks a lot like that kid's game where you connect the dots. And that's exactly what we need to do. We need to connect or loop over everything. So when we get here, we're going to start here. That's going to be our I equals 0. Yeah, I equals 0. We're going to do this kind of thing. Now that we've done that, we're going to go down here, I equals 1. Then we're going to do that sort of thing. Then we're going to skip this one and end up here. And when we're here, we are going to do that sort of thing. And then the final one is this, when that happens. So we need to skip the 3rd, the 6th, and then everything greater than 6. So 7 plus. So how are we going to do that? This is a terrible setup. What am I doing? This doesn't work at all. To do this, we can iterate over this. This is actually going to be equal to 2 because we're starting at 0, and this is going to be equal to 5. So to get these two nice numbers, we need to add 1. So 2 plus 1 is 3. 5 plus 1 is 6. And then we need to do our grid count. Plus 1 as well. If we take the mod of those, this will equal 0, that will equal 0. That should work, right? I think so. And then for limiting this whole thingamajig, we just need not what I had, not the grid count squared divided by 2. We actually need the grid count plus 1 squared minus the grid count plus 1. which will be 9 minus 3, which will exclude these 3 vertices up here. So those are gone. We don't care about those. We do care about those 6, right? That should work. That's what we're going to do. Yep, cool. Now all we need to do is actually implement that whole thing. We've got it propped up over there. Hopefully it doesn't fall over. It's rather precarious, but that's all right. So we have that. What we need is we need I plus 1 mod our vert count equal to 0. If that happens, that'll be our 3 and our 6 from that example. And that should work, because our vert count is equal to our grid size plus 1. We've got that covered. Then this is good. Change that. And then we're connecting, going back to this whole thing. This is going to be precarious. Huzzah! Didn't fall over. All right. So we're going to connect to 0, and then 0 to grid size plus 0. So I'm just going to do this way without any sort of input at all. So just I grid size, and then I plus 1 plus the grid size. And then the next one is going to be I plus 1, and then I plus the grid size plus 1, or plus the grid size actually, and then I plus the grid size plus 1. So that should be our vertexes. That should connect everything. And so as long as that's good, we should get something from this. May not be right, but we should get something from this. So if we run that, we get something from this. Still not right, but we got the important bits. We got all of our vertices were created. That's good. The only one that was skipped was the bottom. And it looks like we are not counting enough, which means I believe I used grid size. Didn't mean to use grid size, meant to use the vert count. Because the vert count is the actual number of vertices in each column and row, not the grid size. That was what was getting me caught up. The grid size is not going to represent what we need it to represent. The grid size represents the number of squares in our plane. Oops. Kind of worked. Actually, pretty close actually. This is promising. So what's happening is we are doubling up. We're pointing to the wrong things. And so we've got 2 triangles here and nothing going this way, which means this is wrong. I plus the vertex count plus 3 put me there. I plus 1 plus the vertex count puts me there. And then this is the wrong one. This should be another I. So I and I plus 1, and then I plus the vertex count plus 1. And then this should get us an upside down. Ooh. Yes, cool. It worked. So they're backwards. One of them's backwards, one of them's forwards. That's why we're getting this, but it worked. So we should be able to scale this up now. Scale it up to 16 with 4, just for testing's sake. We get that, and it looks normal. So now we just need to figure out which one is the wrong way. And the easiest way to do that is guess and check. Don't actually listen to me. I have no idea what I'm talking about. I plus 1 and I. There we go. And then this will either be completely upside down or completely the right way, because all we did was flip the last one. And we should see completely upside down. But the important thing, it worked. We now have a giant plane made out of squares. That's what we wanted. We can dynamically generate a plane. Now we just need to do it correctly. That's the hard part. So we will flip this with that eye, and then we'll put this vertex count over here. Ooh, that was wrong. Deleted the wrong thing. There we go. And now we have a correctly generated plane. Ta-da! Maybe premature. There we go. Awesome. It worked. See, all you need is a whiteboard, and then everything becomes easy. So this is our finished generated mesh. It's just a plane. We can make it as thick or as dense as we want. So if I really wanted to go at it, 256, that should be big. Oh, too big. 128 square, that's still not quite too big. But as you can see, we can make it quite dense. That's 128 squared columns, which is going to be a lot. Like 10,000-ish different, yeah. Anyway, you get the idea. We can make a generated mesh that is a plane. We can do other things too, but we did a plane. Other things are more difficult, and judging by how much difficulty I have with the plane, it's probably a good thing we stuck to the plane. So I hope this was interesting, and I hope you guys enjoyed it. If you did, let me know in the comments what you thought, and I hope to see you guys in the next one. So until then, see you, Internet.